Hello, everyone. Hope you had time for some refreshments in the coffee break because we're continuing our program until lunchtime. And next up, we actually have Tomislav Tipuric, who's the CTO at Nefos, and he'll be talking to us about exploring LLMs across clouds, a year in the life. He's going to be exploring different LLM offerings from Google, Microsoft, and Amazon, talking about their limitations, about their features, about their use cases. He's also going to be covering some challenges in implementing these in custom applications. So without further ado, I would call Tomislav to the stage. And a big round of applause, please.
Thank you, Milos. All right, welcome everyone. As Milos already told you my name, I will not go deep into the topic of who am I. I'm actually been in the industry for almost 20 years. I've been working in Microsoft 13 of those 20 years. So basically my background goes back in the times where cloud was beginning to be a thing, up to the point where you could actually use it in the real world scenarios. And for the last 5.5 years, I'm a private entrepreneur, consultant, educator all over the world in a company called Nefos, which is basically located in Belgrade and Zagreb. So we have colleagues here and in Zagreb covering mostly Western Europe, UK, and USA. Why is it called a year in the life? Because it's been actually more than a year that I started to work with the LLMs on the customer projects. So think of it like this. You probably heard about ChatGPT. Everybody heard about ChatGPT. Everybody tried ChatGPT. I'm actually no longer asking in these kinds of presentations or sessions, even keynotes, who actually hasn't used ChatGPT, because everybody used it, at least to somewhat extent. But have you ever thought about what it actually means? What is GPT in ChatGPT? GPT is actually the name of the model running behind. And ChatGPT is just a pure, simple application, just a simple chatbot that's sending and receiving the requests towards the GPT model in the background. And GPT is called GPT because it's generative, so it means it generates content, any kind of content. It's pre-trained on the petabytes of data nowadays. And it's based on the transformer neural network invented in 2017. So that's what actually GPT means. And you'll see that out there, models that were based on transformer neural network or transformer type of the neural network and this approach, there are at least hundreds of them coming from all over the place, based on pretty much similar story. But not all of them are alike, and there's obviously no time in half an hour to cover all of them. So we are going to be concentrating on the ones that are published and enabled by the top 3. How do LLMs work? Have you ever thought about it? I mean, you write something and you get some result out. So basically you're starting to converse with a chatbot and start to get some content generated. But even though it sounds like magic, it feels like magic to somewhat extent once you start using it, it's not magic at all. It's based on the statistical probabilities. So let's take, for example, we have a sentence, it's raining cats and... Everybody said dogs. And I mean, you would have multiple examples because there are sentences in the English language where this was trained upon. That could be like dogs, or drops, or rain, or fish, or whatever. And all of those have some probabilities that they're actually completing the previous sentence. However, the most probable one is obviously going to be dogs, because it's present in most of the text this model was trained on. And due to that fact, most of the times, GPT models are going to return dogs. I'm saying most of the times, due to the fact that you can play around with the models and you can actually set some parameters to ignore or to partially ignore or to completely ignore the statistical probabilities. And that's how you get hallucinations. So once you ask a question, GPT model doesn't have the probable enough answer, it's going to just randomly choose one based on the probabilities. So it's not exact science, and you can't completely trust it due to the fact that it's all based on statistical probabilities. if the question you're asking was actually present in the data this model was trained on, you will get the answer. If it wasn't, you'll get some answer, which may or may not be correct. So, if you look at the history of the LLMs, as I said, everything in Gen AI world started in 2017. That's what we kind of find the founding moment of the whole AI field called generative AI, because of the transformer neural network, which was published in Google's paper. So it's kind of Google's research that's behind all of it. However, as it happens in our industry more often than not, Google wasn't the first one who actually got there with the most useful LLM model. And you know who it was. It was actually OpenAI with GPT. But let's just take a moment and figure out that there have been many different milestones in the development of the GPT models even prior to ChatGPT. I would argue that one of the biggest milestones where we see impact today is actually August 2021, where OpenAI published the Codex model. Codex model was advanced trained model based on GPT-3. Nobody heard about GPT-3, nobody heard about Codex. Probably nowadays you heard about GitHub Copilot, which is a developer aid coming from AI, so basically enabling developers to code faster, to generate the code. GitHub Copilot was published actually back then in 2021. It was based on the Codex model. So it was the first Copilot coming out from Microsoft, and it was actually the first really useful generative AI tool that enabled developers to code faster. I was using it back in the day. It changed the way that we code. Then it was followed by the most known one out there, which is basically ChatGPT in November 2022, and the rest is history. Nowadays, we got to the point that we not only have text-in, text-out interfaces, which is basically what GPT 3.5 or GPT-4 was all about. We now have multimodal approaches where we can use anything as an input. It can be a picture, it can be a video, it can be a voice, it can be a document, whatever you want. You just put it in, drop it into the model, and the model is going to find its way around it and actually reply via text. Even multimodal models have text as its output. There are obviously specialized models that generate images, audio, and video. But multimodal is multimodal on the input, text on the output. So if you look at the top three, their approach is to somewhat extent different. Microsoft, for example, doesn't have its own research in terms of the LLM world. It's relying solely on the work done by the OpenAI. They have an exclusive agreement with the OpenAI. Somebody's saying, they own 51% of the OpenAI. That hasn't been disclosed. We don't know, actually, what's their relationship inside, but we know that Microsoft has exclusivity on deploying OpenAI models in their own data centers. And that's what they've been doing. And how did they get that exclusive agreement? Due to the fact that they were powering the whole research with their Azure credits. So basically, OpenAI is training their models on the hardware which is owned by Microsoft for free, and in a way, it's getting them the models to be able to deploy them in the data centers. Google has somewhat different approach with its Gemini, and this is probably one of the LLMs that changed its name so many times. It used to be called Bard, it used to be called LLMDA. I mean, we can argue that those are all different models, but at the end of the day, Google was publishing 2 or 3 different models every month, and none of it worked at the end of the day. Until they got to the Gemini 1.0, and nowadays Gemini 1.5. These are all researched in a Google's company called DeepMind. So it's a research center inside of the Google and owned by Google. And if you remember, maybe if you were looking at the AI back in 2016, you would know that DeepMind was the name for the first computer that was actually able to beat Lee Sedol in the game called Go. Maybe some of you remember 1997 and Garry Kasparov losing from IBM Deep Blue in chess. Google's DeepMind was actually able to beat Lee Sedol in Go without being taught to learn Go. It learned from the player, and then it was able to beat it. So that was kind of a really unveiling moment for Google when they actually started their advanced research. Amazon joined this whole battle last. And nowadays, they have their own models, which are under the name Titan. And you will see later on that they are mostly referring to its AI strategy by not just creating their own models, but using the open source models that are out there and actually running them inside of their own data centers. Just a fancy way of saying we are not yet there, so we are leveraging what we can. Basically, if you look at the foundation models that are developed by those vendors, we have Amazon, Google, and Microsoft, and you will see these kinds of tables through the rest of the talk. So I'll be comparing and contrasting different things in different vendors. Basically, embeddings is something which you need first, and I will explain it a little bit further down the road what it is. It's basically vectorizing the text. So let's keep it like that for now. So there's Titan text embeddings, Titan text Lite, which is a small language model. So for most common operations, simple to run, cheaper. And there's Titan Text Express, which is basically a larger model comparable to GPT 3.5. Just to give you GPT 3.5, maybe GPT-4. It's somewhere in the middle. Amazon doesn't have a multimodal model. It only does multimodal embeddings, vectorization of images and text together. Talk about it a little bit later. And in terms of image generation, it has Titan image generator model. That's basically generating pictures, generating AI. You saw it out there. Google has different things. Google Gecko is there for embeddings, so basically vectorization, which we need in search. There's Gemini and Gemma. So Gemini 1.0 is actually text-in, text-out model. And Gemma is the open source variant of the Gemini text-in, text-out model. In multimodal experience, they have Gemini 1.5, which they published in April, if I'm correct, this year. And for image generation, they use Imagen. That's one of the models that's, again, generating images. In terms of Microsoft, obviously, for embeddings, they have some of the smaller versions of GPT models. So basically, all of those text embeddings, Ada, DaVinci, there are those kinds of names. They're all based on GPT-3, basically. They're smaller models, easier to set up, and that's why they are using them for the vectorization purposes. Language models, true language models are obviously GPT 3.5 and GPT 4, so those are text-in, text-out interfaces, and their multimodal experience is GPT 4.0. Probably heard about that one. That's probably, we'll figure it out. That's one of the models that gained most attention once it was deployed in ChatGPT. And if you are paying for ChatGPT, you can also use that same model for your work. Image generation, it's DALL-E. You probably heard about it. For voice generation, Microsoft has Whisper. That's another model that's able to synthesize voice based on either a matrix that you're going to publish. For example, you can record yourself and publish it, give it to the model in combination with the text you want it to read, and it's actually going to read out the text based on your voice. It works quite well. So which one is the best? Who knows? The only thing that we have as kind of a benchmark is basically called Chatbot Arena, which is not an exact science. That's the place where you can actually go and test the models yourself. So you can actually compare two models, give them some prompt, and actually figure out whether or not you are satisfied with the result. And based on the speed it's running, based on your satisfaction as a user, and all of those things combined, they are actually generating some kind of ranking. And this is the ranking that you have out there. So the most popular one currently, the best one that the community is saying is the new version of Gemini, the experimental version of Gemini. The second one is basically the new version of GPT 4.0. So that's the latest one, published in September. And then there are many others following. 0.1 that you can see here is completely different approach. That's OpenAI's approach towards reasoning. I'm not going to cover that today because that would create another whole, open up another can of worms and give into discussion of pre-AGI world and everything else, and I want this to be short and sweet. But you can see that there are models out there, and there's not that big of a difference if you look at it from 1344 to 1308, basically 1301, so that's the first 6 places. But you can see one important thing. The last column actually tells you what's the license to use these models. And all of them are proprietary. All of them are owned either by Google or Microsoft or some of the other companies. And if you look in the world of AI, generative AI is the first field where industry, the companies, the actual corporations, took over the research from the universities. So corporations are now having better results than anything that's possible to do in the university. And it's only because of money and nothing else, and due to the fact that to train those models, you need to have a giant machinery of hardware running somewhere. Universities can't do that, but big corp can. Regarding pricing, due to the fact that Amazon isn't yet there with their multimodal options, we are going to be comparing apples and oranges here, but bear with me. So Amazon, Google, and Microsoft, basically, again, we are comparing the same three vendors. So let's choose Titan Text Express. That's, as I said, text in, text out. It's not multimodal. You can't send it a picture. You can't send it audio, video, or whatever. So it's text only. Input is $1 per million tokens, and output is $0.7 per million tokens. What's a token, you ask? That's probably one of the most complex things you can explain. But if you are into the LLMs, if you are into the language processing in general, or natural language processing, you would know that we usually say that a token is a syllable, pronounced syllable in an English language. It's not exactly that, but it's comparable to that. So basically, pronounced syllable can be converted into the token, and every word has at least one token. So if it's a single syllable word, no matter how many characters it has, it's going to be one token. If it's multi-syllable word, then it can have multiple tokens, again, depending on the language, depending on the way the model was trained. But based on those tokens, we get charged, and we can always see how many tokens we actually spend with our requests. Google, for the Gemini 1.5 Pro, their most advanced model currently, are charging, that's a multimodal model, and they're charging 1.75 for input, and they're charging 5 for output per million of tokens. You can figure out that basically most of your prompts that you're doing to ChatGPT, when you're asking it without that much of a context, those prompts mostly have up to 1,000 tokens. If you're adding like a half a page of a text, that's going to be usually 4,000 to 5,000 tokens. Just keep that in mind as a reference. So 1 million tokens is quite a lot. But obviously, when you have an application that's going to send a request based on your users, you're going to be spending the money. Microsoft has GPT-4o, which is the brilliant one out there, the first one that was able to do multimodal, and that's probably why the pricing is double what Google is asking for. So Microsoft is definitely currently the most expensive one out there, due to the fact that they were first and due to the fact that they have production experience for 2 years now. So, as I said, when you are trying to figure out the pricing, keep Amazon currently out of the picture, because it's really apples and oranges. You can compare Microsoft and Google, which are giving you pretty similar stuff. GPT-4o gives you better results, but it does cost twice as much. So, if you are experimenting, that's definitely something you should try out. So we are continuing with the process when we are starting to use those LLMs inside of something useful, when we are not just testing them. And it's all rooted in the process which is called knowledge engineering. This is the one we had for 20 years now. This is how the search engines started. So we have a set of documents. It can be PDFs, Words, whatever, but it can also be HTML pages. That's how Google started. We are actually crawling through them and building up the index. Index is going to have keywords. Index is going to maybe have some entities that are recognized, people, extracted stuff from the images, depending where in the time frame you were actually using this kind of technology. And once you build this index, and this is doable inside of your company, for those of you using maybe Microsoft's Office 365, if you have documents on SharePoint or using Google Drive, they are already indexing this due to the fact that they could enable you to search through them. So that's the process that's happening behind. Once you have that, prior to the Gen AI, what you would do, you would use some kind of simple app which has interface like a search. You would type in a few keywords, give me the background on the Eiffel Tower, and in a second you would get what? A list of URLs. And then you can click, copy and paste the content and create your new paper, your new blog post, your new email, whatever you're doing. So it would just end up with a list of URLs. LLMs are going, or modern Gen AI applications are going through the exact same process. They're just not stopping with a list of URLs. They're going to open them up and actually generate some content for us. You can see Microsoft Copilot in the top right, you can see ChatGPT in the lower right, and you can see Google Gemini 1.5 on the left side, which is basically telling me where to go have dinner. Those of you from Belgrade obviously know those places. So this is what we've been using. And if you look at the whole generative AI landscape, basically between Amazon, Microsoft, and Google, Amazon doesn't have a productivity suite. Amazon doesn't have a tool like Google Docs or Word or whatever, but Google and Microsoft do, and they created assistants for those technologies. So we have Gemini for Google Workspaces, which is actually your AI assistant inside of Google Docs, inside of Google Sheets, inside of whatever you're using out of the Google Workspace package. The same thing in Microsoft world is actually called M365 or Microsoft 365 Copilot. That's basically integrated into Word, Excel, Outlook, PowerPoint, Teams. So you can basically record your Teams meetings. It will transcribe it. It will enable you to ask questions. What happened in this meeting? Even if you haven't participated in that one. So those are productivity AI assistants that are present as part, obviously, that you need to pay for, and as an extension for the business productivity online suites, like Google Workspaces, like Microsoft 365. There are developer assistants. In Amazon world, it's called Amazon Q Developer. Used to be called Amazon Code Whisperer, because it's whispering the code to the developer. So that's the AI assistant. While you're coding, it's completing your code. In Google's world, that's Google Gemini Code Assist. In Microsoft's world, that's obviously GitHub Copilot. Tried all of them. Microsoft and Google currently have slight advantage, but Amazon is catching up. In terms of chat assistants, ChatGPT, but inside of your company. So nothing more than that, just text in, text out, or sending a few documents or whatever you're doing with it, is basically Amazon Q Business. In Google's world is obviously Gemini. Gemini is the application also, and Microsoft Copilot. That would be equivalent to the ChatGPT. And there are ways that you can adapt those chatbots to create custom experiences, custom agents, custom Copilots, custom Geminis. And in Amazon world, that's done with a tool called Amazon Lex. In Google's world, that's Dialogflow CX. And in Microsoft world, that's Copilot Studio, because their agent is Copilot, so Copilot Studio enables you to adapt it. And also, all three have the offering for the developers, for the companies that are going to be building new AI experiences. That's called Enterprise AI landscape, basically. And there we have Bedrock is Amazon's way of giving you stuff. Google actually has that in Vertex AI, and Microsoft has it in Azure OpenAI, as Microsoft is really deep into the OpenAI world. To figure out how to build those apps and how those apps work, we need to know one important thing, which is called retrieval augmented generation. That's the basic pattern of today's LLM-based applications. What it means? It means that if you're just going to be rely on the stuff that LLM is trained upon, you're going to use the app and talk directly to the LLM. This is how ChatGPT started. You just had a prompt, you were talking just to the model behind and getting the results. But if you look a little bit more further on, you can extend that. And you can extend it with a ton of data that's lying out there in the process where you would first be vectorizing that data. I will explain in a second. And then that would enable you for your app to first start talking to an orchestrator and to get the documents based on your prompt. If you're looking for some game that happened 10 years ago, it's going to look into game database and actually get that data. And then it will combine the document that it found with your prompt, give it to the LLM, and then generate the output. Why this is important? Because that output is going to be more correct than anything LLM can actually turn out, due to the fact that it's based on the actual document inside of your organization. And how does vector search work? Well, imagine that we are running some text through the process. Doesn't matter. I'm not going to go into the technical details. So let's say we have a coordinate system, and we have a vector representation of the word bike. This is the vector for bike. And then we have the word electricity, and this is going to be the vector representation for the electricity. And then we have a term electric bike, which is going to be somewhere here. So what you can see, how as close those vectors are, as close its meaning is. So bike and electricity have nothing in common, but bike and electric bike do have, as well as electric bike and electricity. This is just an illustration, but this is how the search works. Based on the distance between two vectors, that's how the meaning actually differs. So in terms of the RAG ecosystem, to be able to learn, to be able to use these technologies, you need some different tooling out there that's running for you. So first of all, we can have automated retrievers. So these are part of the platforms which give you the search experiences. So it will give you vector search, it will give you the way to store the index, and everything else is there. So in terms of AWS, Google, and Microsoft, we actually have in AWS Kendra and OpenSearch, which can serve as that. So those are the technologies which are complete retrievers. Sometimes you need that. That's the easiest way to start. You just index your documents, connect your application to the LLM and to the retriever, and you are done. Application up and running in 5 minutes. You can try it out in any of the platforms. They all have tutorials. In 5 minutes, you'll have your own RAG-based application. In Amazon, that's Kendra and OpenSearch. In Google Cloud Platform, that's Vertex AI Search. And in Azure, that's Azure AI Search. This technology used to be called Azure Search, then Azure Cognitive Search, and now it's Azure AI Search. Same exact thing. In terms of vector databases, which you can use as a partial way to store the vectorized data, there are proprietary ones in the cloud, and there are also the open source one. In the proprietary world of Amazon, it's basically DocumentDB and DynamoDB. In Google, that's going to be BigQuery. It's going to be AlloyDB, which is their fork of PostgreSQL. So it's basically feature compatible with Postgres, but it's not Postgres. And there's Cosmos DB and Azure SQL databases in preview in terms of vector support, which is basically there. All of the vendors run Postgres. They have the option, and they also have Pinecone, which is proven to be one of the best or one of the first useful vector-based databases for doing retrieval augmented generation. That's why all of them have it. Google has its own Cloud SQL for Postgres, and Microsoft is running either a server or a managed server for Postgres or some variant of Postgres inside of their Cosmos DB. They also support Pinecone. You also need a couple of other things when you are going to be deploying the apps. You obviously need a place to store the documents that you are vectorizing. So you're going to use cloud storage for that. In Amazon, that's obviously S3. In Google, it's cloud storage. In Azure, it's Azure storage. So that's blob storage, binary storage that you can put anything into, and you can use it for your documents. For the managed app environments, where you will deploy your chatbot when it's done. Once you finish the chatbot, you need to deploy it. It's a web application. Basically, it's going to be Elastic Beanstalk in Amazon. It's going to be Google App Engine in Google. And it's going to be Azure App Services in the world of Azure. The whole development and playground studio, basically, all of the vendors have it. In Amazon, that's Amazon Bedrock Studio, because Bedrock is their name for the whole ecosystem. In Google, that's Vertex AI Studio, and in Microsoft, it's Azure OpenAI Studio, the older one, or Azure AI Studio, the new variant that's coming up. So, what you can do with it, there's only the point of your imagination. Basically, these are just some of the examples of all of the things that have been out there for quite a while nowadays. Just like, for example, document process automation, where we are automating the way that we are processing the documents. One great example. Second one, contact center analytics. You heard me talking about whispering, basically being able to transcribe the text and then figure out what's happening with that text. Media companies for actually transcribing the articles, transcribing the videos that are out there, and then generating additional content based on the full-blown solutions that are out there, or basically writing new blog posts or writing new articles, figuring out how to design a scenario or something like that. These are all viable options. For example, comparing the products in the web shop. This is a huge task if you're doing it algorithmically. It can be easily done with vector-based search and comparing of the meaning and the description. Last thing to think about, if you have developers inside of your organizations, they should start today to learn to use Gen AI tools, because they are going to be up to 100% more productive than they are without those tooling. So keep that in mind, because there are things that you can do easily, like generate boilerplate code, generate unit tests, generate all of those different sets of contents out there. If you are a software agency, if you're going to go through this process, keep in mind, it's not about technology at all. It's about changing the process. So as any change management project, if you're implementing any kind of Gen AI tooling in your organization, you're going to need to go through the change management phases. You will figure out the pain points, figure out the tooling that enables you to actually to resolve those pain points, and then you will need to design the future of your organization, figure out which people inside of the org can be the change agents, which are your early adopters, and then you can actually measure the impact that's happening out there. As you might have seen through this really short exploration, generative AI is definitely here to stay, and all of the three vendors have really a good hand to play here, really powerful offerings. It's going to be totally up to you to figure out which way you're going to go, but I suggest start exploring them today and start leverage them for your business as soon as you can. Thank you, and welcome to the wonderful, brave new world of Gen AI.
Thank you, Tomislav.